If I place 1 mole of magnesium chloride and 1 mole of water, which of these two compounds have the greatest number of particles? In today's video, we are going to be learning exactly how scientists are able to calculate the number of particles present in a single atom. You know, atoms are invisible. Atoms are too small to be seen with the eyes. They are microscopic. But how are scientists able to count the number of particles present in atoms? You are going to learn that today. The relationship between the mole and the Avogadro's constant. So you'll be able to convert from mole to number of particles, and you should be able to convert the reverse as well. The mole from mole to number of particles and from number of particles to moles. You should be able to do some calculations, and this is exam focused calculations concerning these topics. How to calculate everything related to moles and the Avogadro's constant. Actually, the mole is simply a unit which is being used to calculate the amount of substance. Amount of substance has a unit called mole, and this mole is also having another definition. What is a mole? The mole can still be the amount of substances which are present in this number 6.022 times 10 to the power 23rd particles. The number of substances which are present in 6.022 times 10 to the power 23rd particles is also considered as the number of moles. When we talk about these particles, what are these particles? These particles could be either atoms. The moles could contain atoms. The number of particles which are present in this number of atoms, or could be electrons. This could be electrons, could be ions as well. Yes, so you can define mole as the number of substances which are present in 6.022 times 10 to the power 23rd atoms, or present in 6.022 times 10 to the power 23rd electrons, and so on. That is how you can define mole. To summarize this, the mole is simply the number of substance which are present in 6.022 times 10 to the power 23rd particles. And these particles could either be atoms, electrons, or ions. That is how we can define a mole. Why do you think these moles are important? Why should scientists be studying moles? Actually, you know that atoms are too small. Like I said, atoms are very microscopic. So it's difficult for you to count the number of particles inside something that you cannot see. They are too microscopic. You cannot see them. You cannot even count the number of particles. So moles come now into play, so that it's going to help quantify the number of atoms or the number of particles which are present in an atom. That is a quantity. We are quantifying it. Yes, we are not just counting. Yes, for example, if you know that one dozen, when we say 1 dozen, you know that 1 dozen contains 12 items, right? When you say a pair of shoes, it means that it contains 2 shoes. These are the quantities, and we are comparing. These are the units. 1 dozen contains 12 items. 1 pair of shoes contains 2 shoes. Therefore, we are also comparing a particular quantity of atom with the number of particles present in that atom. And this is how we put it. 1 mole of any substance contains how many number of particles? Contains 6.02 times 10 to the power 23rd particle. Contains this number of particles. You can relate with all this comparison. You are comparing. All scientists know that 1 mole of any substance will generally contains this number of particles, and the particles we are talking here about could be atoms, could be molecules, could be ions as well. Like you were being taught some years ago, you know that matter can be made of either atoms, could be made of molecules, ions as well. Matter can be made of atoms. It's not only atoms. Some people believe that matter is only about atoms. Matter contains molecules as well. Matter could be made of atoms, could be made of molecules, and could be made of ions as well. So this comparison in chemistry is very important because it helps us to be able to calculate the number of particles inside an atom without actually seeing the atom. We are just comparing. You all know that 1 mole of any substance will contain the Avogadro's number of particles. This number, which I just wrote here, like 6.02 times 10 to the power 23rd, is also known as the Avogadro's constant, or Avogadro's number of particles. So 1 mole of any substance contains this number of particles. 1 mole, let me say 1 mole of hydrogen chloride, hydrochloric acid, will contain 6.02 times 10 to the power 23rd particles. I can also say that 1 mole of hydrochloric acid will contain 6.02 times 10 to the power 23rd atoms. Yes, I can also say 1 mole of hydrochloric acid contains 6.02 times 10 to the power 23rd molecules. Yes, this is how we can use this conversion to be able to get the number of particles or the number of atoms or the number of molecules in every substance that you are being given. This is very important. So this is what scientists do to be able to quantify the number of particles. This mole we are talking about, it has a unit of mole without E. This is a unit of mole. So you don't be confused between this and this. Many people are always confused between these two. This is real name and this is the unit of that mole. And this mole is also having a symbol. Either you write it like this, small n. We all know that all scientists know that small n represents mole. If you write this, it will be well acceptable. Now, considering you have learned more about this mole, you have understood many things about this mole, let's go to how we can relate what is Avogadro's constant. I said Avogadro's constant in number known as 6.02 times 10 to the power 23rd particles was known as the Avogadro's constant. Now, what is the Avogadro's constant? This constant was named after a scientist known as Avogadro. It's a great scientist from which this constant was named. This constant was named after the great scientist known as Avogadro. So he was the first person, he was one of the first person who started studying the amount of particles present in a particular mole of a substance. And because of that, scientists decided to name this constant under his name. If you have been asked to define Avogadro's constant, what are you going to say considering all what we have said here? Avogadro's constant simply tells us the number of particles present in 1 mole of a substance. Avogadro's constant tells us the number of particles which are present in 1 mole of a substance. And this constant is having a symbol L. You can also write L. When you write L in chemistry, we know that this is called the Avogadro's constant. This Avogadro's constant, since it's a constant, it means that it never changes. So you will keep on using it in all your calculations. Any calculations related with number of particles and the moles, you always use this Avogadro's number to calculate it. For example, if you have been given calculate the number of particles present in 2 moles of water, calculate the number of particles present in 2 moles of water, you will still use this same number to get your answer. That is how we are going to do it. Okay, just a brief summary of this. You know that 1 mole, like I said earlier, 1 mole of any substance contains the Avogadro's number, which is 6.022 times 10 to the power 23rd. This is an estimate value. You can always write 1 2 here is okay. Or if you write double 2, it's still okay. It's an estimate value. It's not the real value. Yes, it's an approximate value. And these particles contains the number of particles, right? 1 mole of any substance contains this number of particles. And these particles could either be atoms, could either be molecules, could either be ions, and could either be electrons as well. This is a flow chart of how you can relate all this. 1 mole, Avogadro's constant, number of atoms, number of molecules, ions, electrons. Okay, let me take you to the core concept for today, which is how to calculate number of moles and how to calculate number of particles given a particular type of question. Actually, there is a relationship between number of moles and number of particles. And the Avogadro's constant. There is a relationship between these three: number of moles, number of particles, and the Avogadro's constant. And that formula says that number of particles, when you have number of particles, let me use M, capital N as the number of particles, right? Number of particles is equal to number of moles, which is represented like this, times the Avogadro's constant. This is the main formula which you have to take note of. You have been seeing this in your school. Number of particles is equal to number of moles times the Avogadro's constant. From this formula, you can always get many other formulas from this, because if you are being given the number of moles without the number of particles and the Avogadro's constants, you can always look for the number of particles easily, because I told you that this Avogadro's constant is always a constant. It never changes. You keep on using it, right? For example, if you are being given calculate the number of particles in 23 moles of hydrochloric acid, what are you going to do? You are going to take in your data, number of moles. Like I said, this N stands for the number of moles, right? This N is a symbol for number of moles. which is 23. Avogadro's constant is always constant, which is 6.022 times 10 to the power 23rd. This is Avogadro's constant. So number of particles is a question mark now. You can always calculate it. So how do you do this? Use the formula you have here. Either you use direct substitution or you calculate. Now you are going to calculate number of moles or number of particles is equal to number of moles, which is 23, times Avogadro's constant, which is 6.022 times 10 to the power 23rd. This is how you can always do that calculations, and you get the number of particles for each element you have been given for a compound as well. So generally, I was saying that number of moles or number of particles is always equal to number of moles times Avogadro's constant. From this formula, you can always get many formulas using a formula triangle. Let me use this formula triangle, and we can see how it's going to work. You divide this formula like this, this triangle like this. So number of moles or number of particles is equal to number of moles times Avogadro's constant. Consider number of moles, number of particles times Avogadro's constant is correct for here, right? So if you want to take the number of moles, now if you have been given the number of particles and you are asked to look for the number of moles, you are going to take this number of moles is equal to number of particles divided by Avogadro's constant. You can do this from here. If you want to look for the number of moles here, you are going to divide all through by the Avogadro's constant, right? If you divide all through, you are going to have number of moles is equal to number of particles divided by Avogadro's constant. This formula triangle is true. If you have been asked to look for the number of Avogadro which is present in this data, for example, you have been given the number of particles, you have been given the number of moles, and you are asked to look for the number of Avogadro. So you are going to take number of Avogadro is equal to number of particles divided by the number of moles. You are going to have the number of Avogadro. This formula is very simple. If there is anything you haven't understood well in this explanation, you can always write at the comment section. I'm going to do other videos and help simplify this concept so that you are going to better understand. Chemistry is one of the simplest subjects which you must always have all your marks. Let's apply all what we have learned in solving questions. First question, we are going to apply everything we have learned in this video today. First one, how many particles are present in 1 mole of a substance? They're asking for the number of particles, right? And they are giving 1 mole. So 1 mole is question mark. The number of particles is question mark. And you are being given 1 mole. At the beginning of this video, I said that 1 mole of any substance always contains the Avogadro's constant or the Avogadro's number of particles. So there is no need to calculate. 1 mole of any substance contains this number, 6.022 times 10 to the power 23rd particles. As we are going further, it's going to become more complex as compared to this. This one, you are only asked to calculate the number of particles present in 1 mole of a substance. Number 2, how many particles are present in 2 moles of a substance? So now the number of moles have increased to 2. You are asked to look for the number of particles. So you are going to use number of particles is equal to number of moles times the Avogadro's constant, or the Avogadro's constant times the number of moles is still the same thing. So the number of moles, which is your n, right? Your small n is 2 moles, and the Avogadro's constant is L, which is 6.022 times 10 to the power 23rd particles. So we are going to substitute that in this formula. Number of moles is equal to 6.022 times 10 to the power 23rd. All these times number of moles, which is 2, right? You multiply this by 2 and your answer is going to come out. So after having your answer is going to have a unit known as particles because you were asked to look for the number of particles, right? So your unit, you calculate your answer is going to be a numerical value. You put it in particle, in terms of particles. Number 3, the next question, how many particles are present in 0.5 moles of a substance? So the number of moles have increased to 0.5. You still do the same thing. So the number of moles here is going to be 0.5 and the Avogadro's number is going to remain constant. So 0.5, they are present in 0.5. So we are asking for half of this because 0.5, this one times 0.5 is the same as this one divided by 2, right? Yes, number 4. How many particles are present in 3.5 moles of a substance? All these questions are the same. Let's go to the next level of these questions, which is a little bit complex as compared to what we have been doing now. So number 2, calculate the number of atoms in 4 moles of sodium atom. You are being asked to look for the number of atoms right now. Calculate the number of atoms. The number of atoms is question marks present in 4 moles. The number of moles is 4. 4 moles of sodium. Number of atoms in 4 moles of sodium. And I earlier said that these particles we are talking about, because I said number of moles is 6.022 times 10 to the power 23rd particles, right? And I said that these particles could either be atoms. So if you are asked to look for the number of atoms, so if you are being asked to look for either the number of atoms, the number of molecules, or the number of ions, you will see use the same formula, but your answer is going to be in terms of atoms. So what you are going to do here is number of particles is equal to number of moles times Avogadro's constant. But your number of particles here, you are going to convert it to atoms. So the number of atoms now is equal to number of moles times Avogadro's constant. You substitute the various values given to you. Number of moles, you have been given 4 moles is times Avogadro's number, which is 6.022 times 10 to the power 23rd. So after doing this, you are going to have your answer and attach atoms at the end. The unit is atom. This time around, the unit is atom. So number 6, calculate the number of molecules. Calculate the number of molecules in 0.25 moles of oxygen. So they're asking for the number of molecules this time around. Molecules. And you are still going to do the same, right? Because this formula applies for either particles or for either atoms or for either molecules. Number of molecules is equal to Avogadro's constant times number of moles. So you are going to change this number of particles into molecules. Molecules now is equal to number of moles times the Avogadro's constant. You already know the number of moles, right? And you have been given the number of moles. You have been given the number of moles. So you use this, substitute directly, and have your answer, right? That's how you can do that. But don't forget unit. An answer without a unit is no answer. Though the answer you have here will be in terms of molecules. You write molecules as a unit of that answer, molecule. The next question is going to be a GCE standard question, and that is mostly about application of what we have done, application of this, everything we have done in this video, how to apply it. This question says a sample contains 2.4088 times 10 to the power 24. Calculate the number of moles. The number of moles is what we are being asked to calculate. A sample contains this number of moles of water. Calculate the number of moles. Pause this video, take a minute and do your calculations. Let's see how the answer is going to be. If you are looking critically, you will see that this is just about a simple proportion. We are just doing simple proportion here. Because you know that 1 mole of any substance, don't ever forget this. 1 mole of any substance contains 6.022 times 10 to the power 23rd particles, right? Particles. And these particles could be molecules, so their units are the same. Could be molecules. Now they're asking for, they have given the number of molecules. They have given the number of molecules and they're asking for the number of moles. What are you going to do? So you are going to do a simple calculation. So this number of molecules, that is 2.4088 times 10 to the power 24th molecules contains dash number of moles. Look for this dash. You cross multiply. You are going to cross multiply. So you are going to have 1 mole times 2.4088 times 10 to the power 24 molecule. You have cross multiply, right? This one means that it's going to multiply this, and this one multiplies this x, right? It's equal to 6.022 times 10 to the power 23rd particles. Particles times x. You are multiplying this with this times x. So you are going to look for x. You divide all through by this number, 6.022 times 10 to the power 23rd particles, you divide all through 6.022 times 10 to the power 23rd particle. You notice that this one will cancel this one. You are left here with x alone. Particle is the same as these molecules. They are all the same. So it's going to cancel. You are going to be left with molar alone. So you take 1 times this. The answer is going to be x is equal to 2.40.4088 times 10 to the power 24 divided by 6.022 times 10 to the power 23rd. After doing this, you are going to have your answer and put it in terms of mole. You have looked for the number of moles which are present in this number of molecules. Very simple. This is how you do it. So if you have any question, drop it at the comment section. I'm going to be there to attend to you and how you can fix that particular issue you are having. So the next question, before you are being asked to calculate the number of atoms present in 7.5 moles of aluminum. This one is straightforward, right? Number of atoms present in, they have given the number of moles, right? They have given the number of moles as 7.5 moles of aluminum. 7.5 moles of aluminum. So you are still going to use this same formula. Number of moles, number of particles is equal to Avogadro's number times the number of moles. Number of particles, now in this case is atom. You are using atoms, is equal to number of Avogadro's number 6.022 times 10 to the power 23rd times the number of mole, which has been given as 7.5. Straightforward. You calculate your answer and put it in terms of atoms. That is how you put it. A substance contains 4.2154 times 10 to the power 24th atom. Calculate the number of moles. Is question mark. But from that, your formula triangle, you all know that number of moles or number of particles is equal to number of moles times Avogadro's number. So if you are looking for number of moles here, you are going to divide all through by Avogadro's number, right? Divide all through by Avogadro's number. So you are going to have that number of moles is equal to number of particles all over the Avogadro's number. That is what you are going to do here. So you have been given the number of particles as this, which is 4.2154 times 10 to the power 23rd, or is 24th, 23rd. Divide all through by, you're going to divide all through by the 6.022 times 10 to the power 23rd. After doing this, you are going to have your answer in terms of mole. Okay, this is all we have for today's video. If you like this video, hit the like button, subscribe to this channel so that you are not going to miss any of my video which is going to be